Hello and welcome to your day. I want you to think a little more about simple machines. I hope you had a good experience in the lab last week. I want to remind you just a couple of things and then we'll get you going on some problems today. We use simple machines a lot. I don't know about you. I find I use simple machines a lot. In the last 2 days, let's see, I've done some slightly crazy things. I moved a shed, and to get the shed off the ground, I used a big long lever, shoved it underneath, picked it up. I moved a hot tub, also used a big lever to do that. I also used a ramp to pull the hot tub onto a trailer. Let's see, to pull the hot tub, I actually used a thing called a come along that you might be familiar with. It's a lever attached to a wheel and axle, which runs a pulley, which makes something easier to move. I don't know about you, but simple machines are super handy, and having some basic information about them, I hope you find useful. Hey, a couple of reminders. Simple machines do exactly one thing. And I think this is familiar. I just want to make sure. Simple machines do exactly one thing for us. That one thing, 3 words. Have you got it? Simple machines do this. They make work easier. Unlike my writing today. Simple machines do exactly that. They make work easier. In other words, hey, I had to pull a really, really heavy hot tub yesterday, and it was heavy, and I couldn't exert that much force by myself, but I used a machine that allowed me to put in a small force over a long distance, and what happened was this. The work that I put in was similar to the work that I got out, but the catch, as you probably remember, think about the formula for work. I was able to use a fairly small force, and I got out a big force. But in order to do that, I had to put the force in through a big distance, and I only got out a fairly small distance. So, hey, why use a machine? Well, there's one really good reason to use a machine, and often it makes work easier. And in this case, what easier means is that the output force is a lot bigger than the input force. Now, I'd be tempted to put an equal sign in between these two things, and I can't quite get to that for reasons we'll talk about soon, or maybe you noticed. It turns out the work in is a little bit bigger than the work out. It's close to the same, but it's a little bit bigger. That's because of friction. We'll talk about that tomorrow. But bottom line, I want you to be really, really comfortable with the idea that machines do one job, and that job is to make work easier. What does that mean? Usually it means the small force you put in becomes a bigger force out. So today's question really comes down to how do we think about that? So as machines make work easier, there's a question that I want you to consider. And the question is this: how do we measure how much easier they make work? So the question I'm going to ask is, how much easier? At least I'm going to try. And the answer to that question comes in 2 words, or at least the name of the answer. The 2 words that answer that question is the term, what's the term? Do you know what the term is? MA stands for mechanical there we go, more or less, advantage. Those other words we're after, mechanical advantage. And the idea is that is simply a measure of how much easier a machine makes work. So yes, they make it easier. How much easier? The answer to that question is mechanical advantage. Today we're going to dig into that just a little bit, and I want you to think with me a little bit about how we measure the mechanical advantage of different machines. Let's go there now.